And get started. As I mentioned, this panel is a discussion of the safety standards in municipal environments. We have some international experts here, so perhaps we can start with just a broad question. How are natural gas safety standards addressed in municipalities of other parts of the world? So anyone who wants to jump in and start, please feel free.
Good morning, everyone. I'm an electrical engineer by trade, but have been doing gas transportation in the last 10 years. So have had a different prospect of how the safety standards are implemented. In Canada, we have more than 440,000 kilometers of pipelines, natural gas pipelines, and some oil. And very high safety standards. Between 2002 and 2011, the safety standards have been implemented with 99.99% success. This is very important because you're lucky here in Israel. You have good gas. There's not very much H2S in it. That could be very concerning in terms of impact on human life. It requires continuous monitoring, training, and in the background, strong regulation by the different levels of governments. Over 100 years, many standards have been developed to ensure the safety of the use of natural gas, which is important. Israel has a huge opportunity to be able to look at different countries and pick best practices that suits the site specifics here in Israel. The standards that are used in Canada, some are rely on the Canadian Standard Association, CSA, and the ANSI, the American National Standard Institute. There are federal standards that affect the safety of use of natural gas, transportation and delivery of natural gas. And they're developed by the National Energy Board, and they control the transportation of gas between different provinces or different states, and between different countries. In our case, it's between Canada and the U.S. Also, each province has its own regulation of natural gas on how the safety can be implemented and natural gas can be used in the provinces. And then the third level of regulation and implementation of safety happens at the municipal level. This would be cities and districts that would have their site-specific rules. Overall, natural gas is a clean fuel, environmentally responsible, has exceptional safety record. I was very glad to see the use of natural gas in cars, because some people here, I was even asked by one of the reporters about concerns about risk concerns about use of natural gas. The world today has more than 16 million vehicles run on compressed natural gas with exceptional safety record. So I think that just summarized my point of view about this.
The structure of the safety standards in the U.S. is very similar to Canada. We have a federal regulation. The federal regulators, we call them PHMSA, and they provide a combination of flexible and prescriptive requirements for the pipeline and the distribution companies. States have to at least adopt at a minimum the federal standards, and some states provide additional safety standards on top of that. We as well adopt a lot of American and international standards. The regulators use the standards as a way to reference certain types of things like material characteristics and ways to do testing and ways to do integrity management. One of the advantages of taking that approach is that it takes the regulators out of the engineering business, and it allows them to leave the engineering to the engineering organizations like the American Society of Mechanical Engineers or civil engineers. Lets the experts do the job of defining what those safety standards actually should be, and then the regulations can choose to adopt those standards or not. A couple of topics that are very high priority right now in the U.S. in terms of safety regulations. One is what we call integrity management, making sure that the gas stays in the pipe and that it doesn't leak out into structures and cause explosions. In 2008, we had a very horrific incident in San Bruno, California. 8 people died, and I think 50 homes were destroyed. Billions of dollars worth of damage. And as a result, and the root cause of that was a pipeline that had a section of pipe that had been welded in, a sub-quality section of pipe. And no one knew about it. There was no records of it, and they had increased the pressure beyond what it was supposed to be, and the pipe exploded. And since then, there's been a lot of safety regulations on the transmission pipes added to the system, and it could result in billions of dollars of costs for the natural gas industry to comply with these new regulations. One of the other hot topics right now in the safety standards is related to, I guess it's more of an environmental, but it's the emissions. A lot of the pipe in the United States is old, and it leaks out a lot of methane, which is a very potent greenhouse gas. And there's a lot of emerging regulations now about reducing the amount of gas that leaks out of the infrastructure.
Just to add to what Alicia and Adam both said, I just wanted to point out that they talked more about pipeline safety, and that's more their area of expertise. When I look at compressed natural gas and issues around vehicles, there's a great website in the U.S. Run by the Clean Vehicle Education Foundation. It's cleanvehicle.org, and they have a 4 or 5 page listing of all the codes and standards that apply to CNG vehicles. One of the things that's interesting about that, and Adam and Alicia both referenced it, is the percentage of those standards that are developed not by the state government or the federal government, but that are developed by standards development organizations, groups like ASTM or ANSI or the Society of Automotive Engineers or the National Fire Protection Association. And the point about letting the engineers and the technical people figure out the standards, and then a lot of the federal standards at the end that are the national standards incorporate those other standards by reference. And so that the regulators don't have to be the technical experts on every single issue, but they can build off the collective expertise. A lot of these standards development organizations started in the late 19th century. They've been doing this for 120 or 130 years, and developing all that information and setting those standards. And I think that's a model we need to be conscious of in terms of how we develop and set standards.
Thank you, Curtis, Alicia, and Adam. Do we have any comments from Australia and Norway about how natural gas safety standards are addressed in municipalities around the world?
Most of the natural gas development in Australia, though there's lots of shale gas potential, hasn't been developed yet. Most of the natural gas is offshore development. From a safety standpoint, we have, following our own well-known blowout, we had up to this blowout in 2010, it was very much a case of the government saying to the industry, regulate yourselves. But from 2010 onwards, the government established a national offshore authority known as NOPSEMA, N-O-P-S-E-M-A, and National Offshore are the first 2 letters, and authority is the last one. And they set the guidelines for safety offshore. So we don't have, as such, state governments are responsible for safety issues onshore. Compared with offshore, there's a national authority, and essentially they set the safety standards for everything offshore. That's where we are.
Very interesting.
Regarding Europe, I can contribute on the vehicle side and the gas transportation side. On the vehicle side, I mentioned that we have ECE R110 for OEM builds of vehicles. ECE R115 is a standard derivated from ECE R110 for conversions. ECE R110 is addressing the component and the vehicle level. I think by that this standard is pretty unique. the system itself must be safe apart from the component. This kind of certification is issued by third parties like TÜV and needs to be endorsed, for example, by KBA, governmental organizations in Germany or in Luxembourg or somewhere else in the European Union. On the gas transportation side, we have to do with a little bit more ancient regulations. The ADR rules the transportation of gases, also natural gas, for example, on road gas trailers. The ADR comes from a long heritage of the steel industry and by structure needs quite some time to be adaptive to new technologies. Just for example, until today, when it comes to composite cylinders, which are relatively new to the market over the last 20 years, the ADR never managed to really accommodate the concept of a composite cylinder needing fire protection. Until today, ADR is not regulating fire protection on a composite gas trailer. I find that, to be quite honest, a lack of safety, a lack of security. DOT, for example, a DOT exemption for similar technology takes into account all of this latest development of technologies, and by that is more flexible, but also more stringent in the way they look at things. So I would say leading in vehicle technology, but lacking adoption of new technology in gas transportation. That is the situation we have.
Thank you very much. That's very interesting comments. I'm interested, there was a couple of comments made about the involvement of professional societies, such as the American Society of Mechanical Engineers, as well as outside consulting firms and other private sector vendors. Can we talk a little bit more about what the role of those third parties is in the development of these safety standards for municipalities and state and federal governments?
Yeah, I can start. My prior experience is indeed with different TÜVs in Germany, because they have an influence both on the vehicle as well as the gas transportation side. I have seen great differences in the way they approve and certify things, not in terms of certification itself. Here everybody follows pretty established standards, but in the way, for example, system safety is approached. Some TÜVs have more experience with the subject, some less. This is basically what I see right now in the European Union. Then you find in France, CETIM, and other bodies which also deal with re-inspection. In general, I believe that the subject is well understood. A little bit liquid we are right now still in the hydrogen sector, because that's quite new. But otherwise, I believe that most of these third parties are very well established. They have good knowledge. They give good guidance. Their Asian subdivisions, especially in China, seem sometimes divert very much in the practices they, for example, apply in Germany or in Central Europe in the way they look at things. That's another observation I have, and I do not believe that this is always a positive development.
Yeah, maybe I'll just relate it to the presentation that I had yesterday in terms of the marine compressed natural gas. Somebody in the audience, when we had the break, asked me, because I made a statement that in terms of the degree of simplicity of marine compressed natural gas versus LNG, liquid natural gas. If liquid natural gas was 10, CNG was maybe 1 or 2. And the question was a very good question, is if that's the case, how come we didn't see a whole bunch of marine CNG applications all over the world? And the answer is there's twofold. One is the availability of specialized steel. In order to have 275 bars or 4,000 psi, you needed specialized steel that was not available except for application, and it was very expensive. Now it's made by more than 150 mills around the world, so it's pretty available. But the other point that relates to this question is the rules and the standards in terms of marine CNG. You can have the most safe ship, a marine CNG that engineers can ever dream of, but if there are no rules and standards in terms that are issued by the marine authorities, you cannot enter a port. A port master will not allow your ship to enter a port. So recently these rules have been developed by the American Bureau of Shipping and by DNV and possibly other marine authorities that I'm not aware of. And with the availability of these rules or standards, people are able now to apply this simple application in a much easier way and more abundance. The role of consultants is very important because as a company we have a little bit of the expertise, we can talk about certain things, but in order to be able to develop certain standards requires a lot of concentrated effort and focus, and that comes with experts and specialized personnel that can work and help organizations develop these standards.
I'll answer the question by explaining the rulemaking process in the U.S. Typically, the government will commission a consultant or an engineering firm or some sort of expert to perform a study to determine the need for a certain type of regulation. They'll get the results of that study and they'll use that as the basis for actually writing the language in the regulations. Then what they do is they'll issue we call it an advanced notice of proposed rulemaking. It's a draft version of the regulations, and then they allow anywhere between 30 and 90 days for the public, for the operators, for the industry, for other subject matter experts to provide comments and to maybe identify things that the government hadn't thought of, or to provide a little bit of perspective on the potential cost that this would have for the industry to actually implement these standards. So it's a fairly good way to get feedback on a potential regulation before actually finalizing the rule.
Alicia did a great job summarizing the U.S. rulemaking process. I'll go all the way to the very other end of the process in this. In the U.S., when we talk about kind of enforcement of those things or interpretation of those things, especially when we talk about compressed natural gas, you start talking about with the local fire marshal doing the inspection. When you build a facility in the U.S., you have to have inspections by lots of different local officials. And so those federal standards or those national standards wound up getting interpreted by the local officials, saying, yes, you can do this in your building, or this is the kind of ventilation you need if you're going to be working on methane in your facility. So one of the roles for consultants there, we actually, Noble, along with a couple other companies, hosted training, a statewide training in Colorado for 50 local fire marshals to come and get educated by the Natural Gas Vehicle Institute, who came and conducted the training and walked them through all the processes. Local fire marshals are used to dealing with a whole range of issues other than CNG. I think one role for consultants is in helping educate, not only in developing the rules, but then in the implementation of the rules, helping people understand what it is that they're looking at and helping the regulators and those local fire marshals make the right decisions.
I can make some comment about the situation in Australia. First of all, you have to understand that we don't fabricate anything. We don't manufacture anything. We dig holes in the ground. And consequently, a lot of the equipment comes from somewhere else. So, if you understand, it started from a mining country, and the local department of, like at home, local department of mines and petroleum are responsible for what happens on shore. So, understand the royalty situation now. So everything on shore in your state is the royalty goes to the State Department, the State Department of Mines and Petroleum. Go 6 miles outside the 6 mile limit and it becomes a federal royalty. So you love your islands because if your islands can produce oil and gas, then that's your royalty. So this royalty finances the Department of Mines and Petroleum. So if you're outside of that limit, then the federal government should really be financing whatever rules and regulations there are outside that limit, because you can't afford to adopt rules and regulations. There's no point in adopting those rules and regulations or manufacturing anything that's not in your authority area. That's why we have onshore, the Department of Mines and Petroleum is actually responsible for all operations in mines and in oil and gas, at oil and gas development sites. And they only have, if you like, landmen, and they don't have a large budget. Whereas if you go offshore, where it's the federal government royalty, then NOPSEMA controls the offshore and is answerable to the federal government. So that's where it splits up. Frankly, when it comes down, someone said to me, well, what rules and regulations do you have? We don't have a safety school, for example, in terms of manufacturing equipment, because all of our equipment is manufactured somewhere else and brought to us. So we don't have that. But what we do have is we have training, established training enterprises, institutes of training for offshore, where we are training offshore workers, and they have certain certification to be approved, signed off on before they actually can go offshore. Hewitt training, that's helicopter underwater escape training and so forth. That is part of the responsibility established by NOPSEMA. So it's a bit different when you're manufacturing your own equipment. We tend to follow international guidelines. 9 times out of 10, it's US set. So we get a lot of equipment that potentially is designed in Houston, built in Korea, Dubai, or Singapore, or in fact Norway, and shipped to us. So we're the recipient, but the guidelines for that building, we accept international standards.
Thank you very much, Professor. I'm afraid we're out of time, but this has been a very interesting roundtable discussion with perspectives from all over the world, and I hope it's been useful to the audience as it has been for me. Thank you very much, ladies and gentlemen.